Alright, I remade the circuit here, and I'm very proud of it actually, because it's much more simpler than it was before, and it's much more effective, and it's better, pretty much. What I did new to it, well, first of all, these three flip-flops are behaving exactly as they were in the previous circuits that I had, but I took a break, and after a while of doing something else, after a while I start to question all this motherfucker that I did here, all this shit that I did. Well, it is a good circuit in a sense that it's doing the thing that I wanted it to do, but the problem was well, it's too complicated, and I was in the very beginning when I started this project, I was seeing something. I wasn't sure what, but I could see that it can be made a bit more simpler than it was before in the original circuit. And this is it. This is the circuit that is simpler and more effective, more efficient than the original. So here I linked all the reset pins between them, not only for the three of them, but for the fourth one as well. This capacitor and these capacitors are not needed, and I didn't put them here on my breadboard. I did test them. I did test with them here, but after a couple of tests, I realized I really don't need them. They are more like a reminder, but really they don't. They are not needed, both of them. But if shit goes wrong, I know where to put them immediately. But this pin here, the output, the not Q from the last flip-flop here, is the pin 8 here, and is not connected to anything. It's staying, is floating, pretty much like the other pins that I'm having there. What I did very important also was to link. By the way, this was working absolutely fine without the set pin, which is pin 4 and pin 10 for each side of the chip. They were not linked to positive, and it worked. But I had the exact same problems that I had before with the last button triggering the LED while only these two were active, and it was giving me some false output, pretty much. And if only two or only one or none of them were activated, and I could activate the output of this one by flicking many times and playing with it, the output was opening. This was the biggest problem of this very simple circuit that I had before. Pretty much you could unlock because this is the final stage of the circuit. You can unlock whatever is locked, whatever this circuit it's supposed to do, to keep it locked under a certain code that you have to input. And pretty much all this set lines, wires that I'm having here, connections, were floating. And these are inputs. I realized it too late, way too late. I realized I slapped my forehead with my palm, and I said, holy shit, I totally overlooked this. This is an input, and it should be either put to ground or either put to positive rail. And I tested it. I put it first. Initially, I put it to ground, and it was keeping on the output. It was opening the output and keeping it on, and then I put it to positive, and is letting the functionality to behave as it should. And more than this, any kind of weird behavior of the button, especially the last button that I'm having here on the fourth flip-flop, doesn't matter how many times I'm pressing it without a capacitor on it to suppress the bouncings. Doesn't matter how many bouncing is doing. I actually better say, I wanted to make as many bouncings I can using a wire. A simple wire it will give you the best bouncing possible. Trust me on that. And when you have a connection from here to here, it will bounce the shit of it. And that's my test that I did quite extensively here to check and to see when is triggering the output. With all these pins connected to positive rail, the set pins, this set inputs actually connected to positive rail, it made the chip on the flip-flops behave normally. It wasn't behaving normally before, and I totally miss it. I didn't pay attention. So that's a very big lesson. And I know some guys in the forums told me a couple of times on my other projects to be careful with the inputs, usually on a logic chips, to link them either to positive or negative, but never let them floating, because it will give me erroneous behavior in the chip. And it's exactly what I had here, but here it was a little bit more devious than usual. For some reason I was thinking it's the functionality of the chip, or the functionality of the entire circuit. I was misled, but in the end it goes down to a better wiring and better understanding of the chip, pretty much. And I'm not sorry that I did all the trouble with all the circuits. I learned the chip better this way, and I got familiarized with it way more better than before. And yeah, it's very interesting chip, and it's very interesting circuit as well. I learned quite a lot with it, and I'm suggesting for others to try it out. As simple as it is. There's not much to try when you have the answer already. But yeah, this is what I did here. It's absolutely extremely stable right now. Let me show you how it's working. So all these 1, 2, 3 buttons are opening the same 3 gates as before. The last one is this one from here. It doesn't matter how I'm pressing it, doesn't matter what I'm pressing it here. Everything is stay on. It doesn't switch because I'm not having that functionality anymore from that AND gate that I had it before. But it doesn't matter. What it matters is that this the red LED is in order and finally is opening and is not having some crazy behavior from the button. And these two buttons right here are linked on the same line here. All the reset button and these two buttons from here and here, I only put 2 of them. It doesn't matter which one I'm pressing, it will reset everything. It will reset all of the chip at once. And if I'm doing it inverse, it will not commutate anything. Only one, only in this order, 1, 2. And if I'm pressing this guy, when I was having only 2 of them open, I was testing and seeing if this will open, if this will engage the output, and it did before when I didn't connect the set wire here. And if I'm testing it, I'm taking out the button, and if I'm using the wire, the testing wire, which will give me a lot of bouncing, trust me on that, a lot of bouncing. By doing it like this, you are giving it hundreds of pulses, extremely fast, tens or hundreds of pulses. And when I didn't have those pins, the set pin put to positive, it was moving. It was affecting the output, and this LED was triggering. But right now it's not. When I'm doing this intentional bouncing. No, to the positive it doesn't work. To the positive, only to the negative when I'm connecting it. Theoretically, I should, like this set pins here, I should put these reset pins that I'm having here. They should be linked to positive as well through a 10 kilo resistors, just to not let them floating. Right now they are floating. When I'm closing the switch and connecting them to the ground, only then they are actually to one rail connected. When the switch is closed, all of the reset pins are connected to the rail ground. But with all the switches open like this, they are pretty much floating, and they should be connected to the positive rail with a 10 kilo, with something, with even 100 kilo. But to actually be linked to the rail and not left floating, because they may introduce some further and more subversive errors. But that's a little bit too careful, the circuit is working fine as it is without this to set to positive, and I'm very, very, very pleased, and I'm very, very happy. Actually, it took me quite a while to learn my mistakes and to learn the chips, because it's a learning process, and it was a fun project. It was a teaching project actually, and it's absolutely amazing that it's working, and doesn't matter, no. Doesn't matter how many presses I'm doing here. Like before, I was having the problems with it when he was resetting by itself, and oh wow, now is absolutely awesome. Very, very strongly, very good circuit build, this one. So this is it. Thank you very much. I hope you like it, and I hope you learned something with me today. Yeah, I am a bit tired of it. And next I will have to put it implemented in reality on a cardboard. Exactly this very, very simple solution that I'm having here, and very efficient one actually. Yeah, very good circuit, excellent for teaching, for learning. Da. Thank you very much, and I'll see you later, I suppose. Bye bye. Alright, this is a circuit, as I just show it in reality. This capacitor is very optional here. You might not actually need it at all. Theoretically, it's for bouncing the button, but the button itself is fine. Doesn't matter how many bouncing is doing. I tested it with a wire, and testing it with a wire, trust me, it will give you a lot of bouncing, and it's absolutely fine. Like I said, I made this, I linked all the set pins to the positive rail here on the top. Here in Proteus is working with the set linked to the rail or without it. Proteus doesn't care about this little detail here, unfortunately. But in reality, I got some pretty nasty errors from this last button specifically, and it was I strongly believe it was these inputs that I neglected. I literally didn't see them in time. But that's why a project is called a fun project, is when you learned something that I did knew it as a general rule. All the inputs should be linked either to positive or to negative, but I highly neglected this information, and I overlook it, and it cost me dearly. It cost me 2 days. But now I learned I should be way more careful, especially with this particular chip, but with all the chips in general. All the inputs should be linked. For every chip, negative circuit should be linked either to positive or to negative. This is super cool. This circuit will be, I will build it on the final board, cardboard, and I will again, this is more a fun project, and I'll not literally use it for anything, but it's a project, and that's it. Yeah, thank you very much, and see you later. Bye bye.